Dear Face, we can start the meeting.
Good evening, everyone. A very warm welcome to all of you to another session of our industry-oriented training on Python programming for AI and data analytics. In our previous session, we explored the fundamentals of probability and distributions, gaining an understanding of how uncertainty is measured and how data is represented using statistical distributions. Today, we build upon those foundations by exploring two essential concepts in statistics and data analysis: correlation and testing. Today's lecture will focus on relationship analysis and significance testing. Correlation helps us measure the strength and direction of relationships between variables, allowing us to identify patterns and associations within data. Hypothesis testing, on the other hand, enables us to determine whether the patterns we observe are statistically significant or simply due to random chance. Together, these techniques form the backbone of evidence-based decision making in data science, machine learning, and research. These concepts are widely used in predictive analysis, business intelligence, healthcare, finance, and scientific research to validate findings and draw meaningful conclusions from data. A strong understanding of correlation and hypothesis testing will help you analyze datasets more efficiently and make informed data-driven decisions. I encourage everyone to actively participate, follow along with the practical examples, and ask questions throughout the session. Developing a solid grasp of these statistical techniques will greatly strengthen your analytical skills and prepare you more for more advanced topics in AI and data analytics. It is now my pleasure to welcome our esteemed mentoring speaker, Dr. Meher Chand, Associate Professor at the Farid College of Engineering and Technology, Bathinda. Through his expertise in artificial intelligence, machine learning, computational sciences, and data analytics, he continues to inspire learners with practical knowledge and an industry-oriented approach to solving real-world problems. With great pleasure, I invite Dr. Mehchan to kindly lead us into today's session. Over to you, sir.
Thank you, dear Face, for nice introduction. And dear participant, good evening, all of you, and welcome back to this ongoing tutorial series on industrial training program, specifically for Python for data science. I'm going to share my screen, and I hope that my screen is visible to all of you. So the topic which we are going to cover is, this is the 34th lecture, okay, and correlation and hypothesis testing. So in the very beginning, correlation we have discussed, and examples we have introduced, but mainly during this session we will focus on hypothesis testing. Okay, so if what is the meaning of hypothesis testing and why it is required? So actually the thing is, it is a statistical method used to make the decision about the population based on sample data. Okay, so actually when we want to take some decision, so we have to collect the sample of the data, not the population. Okay, population means just like we want to study the problem of the farmers in the Punjab state. Okay, so the population is entire, all the farmers in Punjab, and sample means we will select district wise 100 farmers or 50 farmers according to the size of the district. Okay, not considering the all farmers. So on the basis of some selected data from each district, district wise, okay, whether we are taking the 100 farmers or 10 farmers, so these are the sample. And on the basis of the sample which we collect from the population, we have to decide according to the assumptions whether the assumptions are acceptable or not. Okay, so hypothesis testing is the systematic process of deciding whether a statement about the population is likely to be true or false using the simple data rather than guessing or rely on the probability and statistical evidence. So if we say hypothesis is simply an assumption or claim that can be tested using the data. For example, a new teaching method improves student performance, a medicine lowers the blood pressure, a fertilizer increases crop yield, etc. So, for more detail, we will discuss through the. I have developed some more content. Okay. So first, we are going to start from this file correlation. So actually, in the correlation, for the correlation, we are using here for different tests also the same data set, healthcare data set. Okay, I'm using this file. Okay, so I have already prepared all the files which I require to present here, and some their respective uh, cheat sheets which will be very helping to you to understand all type of the test which are essential for hypothesis testing. So first, we are using here loading the data set. Okay, so I frequently can complete this part which are essential from this place. You can see when you will download the data set, we have this content, and I have already shared this file. So there are two methods for correlation. One is Pearson correlation, and second is Spearman correlation. Okay, and just 1 minute, I have to open correlation hypothesis testing. Okay, yes. So here in this file, we can have some more detail about the correlation, just like a positive correlation. You can see this is straight line, which will be inclined at 45 degree, and the value of R will be equal to 1. Then you can have the strong positive correlation, the value when we have lie between 0.7 to 0.9 approximately. We have a strong correlation, as you can see in the second graph. Similarly, we have the moderate values when lies varies from 0.4 to 0.69, and weak when we have 0.1 to 0.39. Okay, and when the value of R is equal to 0, it means there is no correlation. So all these are for positive correlation, and similarly we can have here you can see the negative correlation. Okay, so here the graph will be as x will increase, y will decrease. Okay, so here when the value lies between minus zero point 0.1 to 0.39, we have weak negative correlation, and if the values lies between minus zero point 0.4 to minus 0.69, this is the moderate correlation, negative correlation, and here is the strong negative when the values lies between minus 0.7 to minus 0.9, and perfect negative when we have the value is equal to R equal to minus 1. And if the value is R equal to just some time when you will import the data set in your using the pandas library, and when you will visualize. So these diagrams which you can see with the help of the scatter plot. So here when you can see the circles which you are observing here, these are the scatter plot. Okay, and on the behalf of this scatter plot, when we will fit the curve, and when we will calculate it, so we can have the straight line. Okay, you can see here is the straight line which will represent and help us to understand the correlation, and numerically along with we can calculate the values of all the data set. Okay, so according to the value of R, we can decide whether it is a positive or negative, and how much these two variable are associated with each other. Okay, so here you can see the other special case when yes, we need to see this is the Pearson correlation. Okay, so Pearson correlation we are using when we have the data. We can have some, yes. Pearson correlation. So these are the assumptions you can see. Variable are continuous and relationship is linear. Okay, and the data are approximately normally distributed, no significant outliers, and observations are independent. And on the other case, and the values, this is the required formula if we need to calculate manually, but here we are using the computing tool with the help of Python. Okay, so we are not required to remember these formulas, but the understanding is very, very important. Without having the understanding, the values which we are getting are useless. Okay. So the files which I have prepared cover all these files. Will be there the test which we will apply. Okay. So here when you will apply the Spearman correlation, here you can see the assumptions. Variables are ordinal, interval, or ratio, and the relationship is monotonic. Okay. So when the relationship is monotonic, either monotonically these are increasing or decreasing. Okay, no requirement of the normality in the here we are required normality in the first one. Okay, this is the okay, just 1 minute. Okay, so these conditions assumptions we are required to understand robust to outliers and observations are independent. So here you can see the other special cases which are associated with the Spearman correlation. Okay, so here you can see the monotonic positive, the values are increasing like in this way. So here the curve when you will fit will not be linear, this will be non-linear. Okay, so rs will be greater than 0. And in the second one, this is the monotonic negative. You can see the curve is decreasing as the value of x is increased, the that of y is decreased. Okay, and if with the data set is like in this way, which you can see in the 13 graph. Okay, so in that case, the value of r will be 0. So here we have only the rs is greater than or less than. Okay, according to that we have monotonic positive or monotonic negative. Okay, if the value of r by using the Spearman correlation method, if it is equal to 0, so completely random pattern, no relationship. Okay, and if you have the data set when you will import and visualize the scatter plot. Okay, so if this appear like in this way. Okay, so in that case we can say a non-constant variance and heteroscedastic relationship. Okay, so these are the some types, so that when you will import the dataset and when you have the scatter plot, so when all these options which we present in this sheet will help you to understand about your data set. Okay, when you will compare two variable three or pairwise plot by using scattering. Okay, so you can easily understand what type of the relationship between the two variables from your entire data set exists, whether this is a strong relationship or not. And here is you can see the values. Okay, if you can go through, you this will help you the about how much strong or weak or moderate correlation. Okay, according to the values of r, this the table is given here, and also along with the values in both the case, whether you are using the Pearson or Spearman, the value always lies between -1 and 1. Okay, so this also you can go through the detail about this one, this method, and along with the Python examples, if you will apply the method, how you can use. So examples of the Python are also demonstrated at the place. Okay, so this part about the hypothesis testing we will cover in the next sheet. Okay, I exempt this part, and these are the some important applications where you can apply. Just like you can see here, healthcare research, finance and economic, marketing analysis, education research, and so on. Okay, and in the case of if you are developing any machine learning model, prediction model, or you are required statistical analysis, etc. So correlation play a very, very important role to develop any advanced technique, because if we are thinking about to develop any machine learning model for prediction and recommendation, so to understand the relationship between the variables is very, very important. Okay, if there is any variable which is not associated with anyone, so that is useless and we can drop the same. Okay, so these are some key takeaways, main key point you can go through. And when we have the heat map, okay, you can see -1 to 1. Sometimes you saw that when we plot the graph, specifically heat map, there is a bar. Okay, so bar represent the values from -1 to 1. Okay, and with their correlation relationship, just by using the colors only. Okay, so this is all about the correlation and overview about. Actually, we have studied already about the correlation. So this is the first sheet, and the second one we have is the hypothesis testing. Okay, so okay, so these points will help us how we can apply the hypothesis testing, what is the meaning is, okay, and what type of the hypotheses are there. So when we will apply hypothesis test, because based on the we have the assumptions, so assumptions can be true or can be false. Okay, so simply an assumption or the claim that can be tested using the data, just like we have the example, new teaching method improves the student performance. Okay, so it can be true or it can be false. Okay, so we have to apply step by step scientific technique. Okay, a medicine lowers the blood pressure. AI based diagnosis is more accurate than manual diagnosis. Okay, so the assumptions alone are not enough, we need statistical evidence. Okay, without having the evidence we are not able to test whether the technique which we are applying is true or not, or having the fruitful result. Okay, so these are the some key terms which are essential to understand here. Okay, just I have the overview. For more detail, you have to read this entire chapter. But here we collect only the important informations which we can use here. Okay, so population is the entire group of the interest, and sample will be always a subset of the population. Okay, so the parameter theta, this is the numerical measure of the population. When we will use the a real example, then you will understand the importance of this theta. Okay, so this is the only the assumption. The static null hypothesis, we denote it by the symbol is S0, default claim, no effect or no difference. Okay, and in the case of alternative hypothesis, we denote it by H1. Okay, so this will be the opposite of H0, what we want to prove. Okay, so the significant level alpha, that will be a probability of the rejecting the S0 when it is true, and commonly we are using 0.05 or 0.01, but most of the real cases we will take only 0.05. Okay, and the most important parameter is p value. So on the basis of the two values, which are alpha and other is p value, on the basis of these two parameter, we will decide whether it is reject or fail to reject. Okay, so p is the probability of the observation of the data as extreme or as more the sample result assumption S0 is true. Okay, and there will be two type of error. Type 1 error will include, and we denote it by alpha. Okay, rejecting S0, we are rejecting S0 when it is true. We assume that it is true, but rejecting S0. And type 2 error, we denote it by beta, failing to reject S0 when it is false. Okay, so these are the two type of the errors. And power 1 minus beta, what is the meaning of this? The probability of correctly rejecting H0 when it is false. Okay, so this will be the value of how much it is close to 1. Okay, according to that we will decide. So this is the real scenario, how we can apply all this and how you can test. These steps are very, very important for you. So first we will state the hypothesis testing formula H0 and H1 and clearly define what is the meaning of H0 and what are the meaning of H1. Okay, for the null hypothesis we are using here S0, and for alternating hypothesis we are using H1. Okay, then we have to choose the value of alpha, and most commonly in all type of the test we are using 0.05. This is the value of alpha. So when we will apply the technique, the value will be 0.05. Then choose the appropriate test. So there are different tests, just like a t-test is there, ANOVA test is there, okay, chi-square test is there, and there along with there are several types of these tests. So all type of the tests which are essential and which you can apply, I try to introduce here. Okay, so some of them I will present here, and some of them you can try yourself. Okay, but I'm not able to present all the tests here, but all type of the detail which you can apply, but how you can do, I will present here. Okay, so this is the fourth step: collect the data and compute the test static, where you will apply test. Actually the thing is, when you will choose the test, okay, there are some conditions, some depend upon the size of the data set. Okay, according to that you will choose the test. Okay, so which type of the test is applicable, but before that you must be familiar about the type of the data and the conditions under which condition you can choose one particular test. Okay, so we must be familiar about all these conditions, and when we will apply these tests along with the in Python. Okay, so otherwise when we do manually we have to we have the other processor to calculate the value of p, but when we are using Python here, so along with the when you will apply t test, we have the value of p also. So this will reduce the time. Okay, because we are using computing with the help of a Python, we are doing all these things. Okay, so that we can easily apply these tests for the real data set. Okay, so remembering the formula is one thing, and applying for real purpose is another thing. Okay, for that, because we have some real problem, we are using all these concepts to solve the problem. Okay, what is happening there? So when you will choose the real problem, we are not required to remember every formula, but the concept about the formula and which type of the test you can apply. So all this information I collect in the one single sheet, and we will discuss about all this. Okay, and test wise also I create some sheets so that you can have more information to understand all type of the data set. Okay, but for this topic you need to spend some more time. So these are the conditions, the step number 6. This is important. So to calculate the value of p and to calculate the value of a test which you will apply according to your data set problem. Okay, at this stage you will decide if the p value will be calculated by using some test. Okay, which you will apply. So from that place you will have the value of a t-test, along with you have the value of p. Okay, p value means the probability. Okay, probability value. Okay, if this probability value is less than and equal to alpha, and the value of alpha is 0.05, 0.05, this is the value of alpha. If this value is less than and equal to alpha, then reject S0. Okay, this assumption will be rejected. If p is greater than alpha, failed to reject as zero. So this is the condition, and on the basis of this condition, we can decide what should be done. And when you have these values, then we have to interpret, draw the conclusion. So this procedure we are required to understand. Okay, these 7 steps are essential, and when you will follow all these steps, this will make all the test of which will be applicable for your data set easy. Okay, so just you are required to understand hypothesis and these steps which are involved here. Okay, so here you can see, yes, so this is the same part. Okay, if the okay, here is one tailed, two tailed, okay, one tail left, one tail right, depend upon the value of theta, which is less than theta zero. Theta zero is like alpha. Okay, and when we have h1, theta not equal to theta zero. So by nature, we can have a sample h0 specifies the exact value, and simple h1 specified the exact value. Okay, and okay, so composite h1 we have the specified the range or inequality. So this will be more understandable when we will apply for real problem. Okay, so this is the decision where you can decide whether the assumptions are according to the value of p we have already discussed, and these are the tests. Okay, these are the common tests at a glance. So we have the z test, we can have t test one sample, we can have t test two sample, okay, t test pair, then we have the chi-square test, goodness, and etc. And along with we can have when we should use. Okay, their conditions are given here. So z test can be applicable when sigma is known or greater n is greater than 30, and this test is applicable when sigma is unknown and small sample. Okay, sample set must be small. Okay, so these conditions we have to keep in mind, and these are the some mathematical expressions are there. Okay, so these will help. These are the some distributions of the data set. Okay, and here we have the some common distributions which you can choose here. Okay, so this is the here you can see the mean value is 0 and the standard deviation is 1, and here you can see for this z test, first one. Okay, so half is, you can see the red color on left side and right side. Okay, so this is two tail. Okay, so partially we have on the left and partial half is on the right hand side, and here is also we can see the symmetric heavier tail than normal. You can see here minus t alpha by 2 on the left side and small on the right hand side. And if the data set is chi-square right skewed, you can see at this place. And for the same f distribution, this area you can see which be accepted or rejected according to, actually this is the major part. Okay, if the values lies here, then this area is acceptable, which you can see white space. Okay, so the other information you can also go through, and these are the what conclusion means. Reject S0, there is enough evidence to support the alternative hypothesis, and fail to reject S0 means there is not enough evidence to support the alternative hypothesis. Okay, so this is all about the tests which we are required to apply, and main tests are here. Okay, so see how we can apply all this by presenting one example. (34) Okay, so first come to we were talking about the hypothesis testing. Then first test we are required to implement is t-test. This is the t-test. Okay. Yes. So here we define very clearly about the t-test. Okay, so all these tests will help us to use in hypothesis. Okay, so this is the first one. What is t-test? So t-test is a statistical test used to determine whether there is a significant difference between the mean of two groups or between sample mean and the population mean, especially when the population standard deviation is unknown. Okay, and the sample size, see, this is the condition when the sample size is less than 30. Okay, or data are not normally distributed. So this is the condition when you can apply this t-test. And what are the key factors? Okay, key concept, population, we have already discussed in the previous slide. We are required to calculate the mean of the sample which we have collect. We are required to calculate the standard deviation of the population and the standard deviation of the sample. Okay, and this is the standard error which is s upon under root n. And t static measure how far the sample mean is far from the hypothesis mean of the terms. Okay, so when you will apply, so from this we are able to understand, we are able to measure how far the sample mean is from the hypothesis mean in the terms of SA. And what is the meaning of freedom? Degree of freedom. Okay, so actually if we have the value of data is n. Okay, so degree of freedom will be n minus 1. Depends on the specifically type of the data set. So according to that, we will choose. Okay, according to the t-test. And p-value, this is the probability of the observing the data as extreme. Okay, so both are required. One is the t-static and the second is probability value. But when you will decide whether the assumption will be rejected or not, actually we can calculate the t-static value, but this is the not enough whether the assumption or a hypothesis which we assume is rejected or not. Okay, but only the p value will help us to decide on the basis of p value. Okay, so this step we have already discussed. The same steps are here, but here new thing is this third step number. Choose the appropriate t-test. Okay, based on the data type, sample design, and assumption, because there are different types of the three type of the t-test. Okay, one of them we have to choose, and after deciding, then we will compute the test static. Okay, which we have choose, and we are required to calculate the p-value, and here make the decision. And always you will observe that when we will decide, there is no importance of the t-static value. The importance is only of p-value. Okay, on the basis of only p-value, you will decide whether you will reject or fail to reject H0. Okay, so this will depend upon the value of P less than or equal to alpha, then reject H0, and if P value is greater than alpha, fail to reject H0. And then after we will draw the conclusion. Okay, so this also you can go through the assumptions diagram is also there. This area and this area you can observe here. Okay, so this part is very important. The value when we assume fall at a place, so we have to accept. Okay, so other things you can easily go through. The test formulas are given here. Okay, so the formulas which exist for the t-test we have is one sample t-test, okay, when you will apply mean versus known value. Independent two sample, okay, when we have equal variance pooled t-test, okay, and this is third one, independent two sample t-test unequal. Here is equal variance and here is unequal variance. Okay, so all these are the types of t-test. Paired sample t-test, matched pairs. Okay, so according to that, and on the right hand side, we try to explore more about the test when you will use. So what you will do before using or before choosing the test, this information which I put in the last column in this table, compare the sample mean with the population mean. Okay, this comparison is essential. Okay, and then compare means of the two independent group population variance are equal. Okay, this must be equal. Then you will choose this independent two sample t-test. And here we will compare the means of two independent group population variance are not equal. When these are not equal, we will choose this test and compare the means from same group at the two different times or matched pair. Okay, then according to that, we have to apply the paired sample t-test matched pair. If the pairs are matched, then we can apply this one. Okay, so here the symbols which we are using in all these tests we have added space, and here are the some examples are given. Okay, so these are numerically when we do manually, you can go through all these examples. Okay, now we check one example. Uh, just 1 minute. Okay. My screen is visible?
Yes, sir.
Okay, just 1 minute. One minute, please. Screen is not visible now, right? Okay.
Yes, sir.
Okay, okay. Just 1 minute. I am checking. One minute, please. Convert. Correlation and Spearman. Okay. Here, look at that. My one file is missing. Poison square. Computational. Please give me 1 minute. My file is replaced anywhere. 1 minute, please. I hope it is now in the right place. Yes. Okay. Yes, you can see now. So here we are applying t-test with the Python. Okay. Yes, it's fine. So here we have one sample, independent two sample, and paired t-test using Python. So all the three tests are here, and it's very quite simple to apply here. So I will execute this entire file. Yes. So here we have these libraries we are familiar, and from the scipy.states, from this library we are using here three tests. So here you can see tt test one sample, tt test underscore independent, and t test for dependent. Okay, so these three tests are there according to our data set. Okay, pair t test, this one, last one. Okay, so what you will do, we first importing the data set, because we are using real data set, healthcare dataset.csv, and when you will import here, this is the data set. Okay, so first we are using one sample t-test. Okay, so here the value you can see h0 and h1, mu is equal to 45 and not equal to 45. Okay, so here we are applying t state. Mu means, what is the meaning of mu? What is the meaning of mu?
Mean, sir.
Yeah. Okay. So here, see here, this is the way how we can apply. How we can apply. This is the way. So all type of test, when you will apply, you will always get two values. Okay, at the same time when you will apply the test. So here we are using t-test. So we are using a t-state, comma p-value. Okay, so all type of the test, when you will apply, p-value will be there, and we always compare p-value. Okay, So here you can see t test underscore one sample, and we are taking age. Okay, this is the variable, and mean is 45. So here when when we execute, so we have two values. Okay, one is t static value and other is p value. Okay, and the third one is the decision. So according to the p value, you can see here decision reject s0, reject h0 if p value is less than 0.05, else fail to reject s0. Okay, so the logic which we apply at the place according to the decision. Okay, we mention here everything, so automatically this will return whether this is rejected or reject to fail to reject. Outcome will be automatically there according to the value of p. We are comparing the value of p only, you can see here. Okay, so we can calculate the value of t static, but this is not enough. Only by getting the value of t we are not able to decide. Okay, p value will decide. So you can see when you will execute, we have already executed all the files. Okay, so here you can see this is the t static value. Okay, and you can see the p value. P value is 0.0, which is less than from 0.05. Okay, so here the condition is true. So if this condition is satisfied, then reject S0. Okay, similarly when we have the two sample t-test, so here we take the two variable. You can see a male and female from the entire data set, and you are familiar now how you can get the separate variable. So you can see the amount, billing amount is there, but for one group is male and other group is female and same category. Okay, so how you can apply? The left side is same, t state p value, and this is the second test, t test underscore independent, male and female. Okay, then this will calculate the t test value from these two group and will store inside t state, and also the p value will store here in the p value variable. And by using these two statement, we can print the t state and p value both. Okay, and also decision depend upon only the one value, that is p value. Okay, so when we compute all these values, you can see the value of t static is there, the value of p is also there. So when you will compare this p value is 0.25, which is greater than 0.05, not less than 0.05. You can compare. This is the p value, and this is the value of alpha, which is 0.05. Okay, the p value is greater than, so fail to reject H0. Okay, what is the meaning of fail to reject? What is the meaning of fail to reject? And what is the meaning here? Reject S0 and fail to reject. Anyone, please? Anyone, please? Assumption which we have assumed. Okay, so either this will be true or false. Fail to reject means true. Okay, the assumption which we have considered is true. We are not able to reject S0. we have to adopt. Then we have the paired t-test. Okay, so this is the way we have the two different data set. Okay, but here we have the condition at one particular time, before and after. Okay, when we have the data of the patients, when we started up any treatment, what was the condition before starting the treatment, and what are the condition after the starting the treatment? Okay, so we have two type of the data set. So before and after. For example, and you will apply here the t-test relevance. Okay, so before and after, and this is the way how you can apply. And the same thing we have, this condition will be always same. Either the assumption the S0 will be rejected or fail to reject. That depend upon only the value of alpha. Okay, so here you can see the value of t and value of p. So the value of p is very, very small as compared to 0.05. Okay, so what is the meaning of minus 0.06? Can you please let me know about this value? If sometimes you are not able to understand this one, copy and paste in the chat GPT and ask interpret these values. You will have complete detail about these values. So sometimes if you have any challenge, any problem, you can integrate generative AI tools just like ChatGPT is there, Gemini is there. Okay, and in the coming sessions to learn all these things, because we are required detailed interpretation. So if you will use take the help from these generative AI tools, these will interpret in very detail. I myself will not be able to provide all the complete detail, but these generative AI tools will provide complete detail and help you to write the report also. Okay. So also we can visualize the data set. This is part we have done already. So the decision rule, you can see this is the decision rule. P is less than 0.05 reject, and P is greater than or equal to 0.05 fail to reject. So always this rule will be there, and we have to adopt, we have to apply this condition. Any question? Any question in this slide, in this example which I tried to present a t-test with Python? So all the tests we have different conditions we have to keep in mind, and without following the condition, by default we are not get the exact information or the results which we need, or scientific study possible only if you are choosing the right test for the right problem. But for that you must have the clear the concept, deep understanding about each test. Okay, along with their conditions when you will apply which particular test. Okay, so you have to follow all the conditions before applying any test. So come back and correlation chit chat we have discussed. This is the chi-square test, right? Okay, so when you will go through all about, you have to keep the some key concept, what is chi-square, when you will apply, type of the chi-square test. These are three type of, just like goodness of the fit test. Then we have the test of the independence, test of homogeneity. Okay, determine whether different population have the same distribution for categorical variable. And second one will be applicable when determines whether the two categorical variables are related or not. Okay, so goodness of the fit test compare observations frequencies with expected frequencies for one variable. Okay, so these are the three type of the test. Okay, and these are some key points you can easily go through. And the hypothesis test will remain same. Okay, so H0 and H1. H0 means the observed distribution fit the expected distribution, and H1 will be here. The observed distribution does not fit the expected distribution. Okay, so one will be true and one will be opposite, alternate. Okay, so one H0 which you have assume, or one which one you have assume or expect, and H1 will be alternate. Okay, so all type of the test you have to follow these H0 and H1. Then you need to apply which type of the test you will apply according to the problem. Okay, so the decision rule for each test will remain same. Okay, you can see the decision rule which we apply for the previous one, the same is here. Okay, p value less than or equal to alpha, reject S0. Okay, sufficient evidence against S0. Okay, if p value is greater than alpha, fail to reject S0, insufficient evidence. Okay, so these are the some common level you can see. And also we can have the this is the contingency table, observed frequency, just like you can see here are the rows categories, and on the top we have the this is the row categories of X, and here we have the columns categories of Y. Okay, so this is the table. So expected frequency table, you can see here EIJ, row total, total I, and column total J upon grand total. Okay, so here all the parameters which are used here in the formula are described. Please go through here. Okay, so this is the chi-square distribution. You can see DF is the, what is DF? What is DF? See here, degree of freedom. Okay, here the degree of freedom will be calculated R minus 1, C minus 1. R means row, number of rows, and C means column. How many rows are there? How many columns are there? So by using, because here we have X variable and Y variables, both are there. Okay, so X categories, and here we have Y categories. So if you want to calculate the degree of freedom, then this is the formula. DF is equal to R minus 1 and C minus 1. Okay, when we have one dimensional, in that case we have only R minus 1 or N minus 1. Okay, so here we have two dimensional. So for that we have, this is the degree of freedom to compute here. Okay, so all the information about each test I include here. Okay, so this is the critical values. You can see the alpha, then we have alpha equal to 0.05, and these are the DF. If you will apply manually, then this table is important. But we are using here Python. So only the Python when you will apply, and this will automatically calculate the value of P. And P, on the basis of P, we are able to decide about the assumption, H0, accept or reject. So if you want to do calculate manually, so examples here are given, and formulas how you can apply the examples are given here. Okay, so please go through the entire information which I try to introduce here in this cheat sheet. I think one more session is required to complete the entire all the examples. So this is the ANOVA test. Just I'm giving you the overview about all the tests and what you are required to remember and what you are required to follow. Okay, so here, what is ANOVA? Very useful. It is a statistical technique used to compare the mean of three or more groups. Okay, sometimes when we have more than 2 group, means 3 group, 4, 5, 6 group, and we are required to compare them. Okay, then we have to apply ANOVA test. So first thing is when you will apply ANOVA, this is the condition. Okay, and there are 3 types: one-way ANOVA, two-way ANOVA, and repeated measure ANOVA. So these are 3 type of category of the test, and we have to remember. And when you will apply these 3 different tests, okay, so you will get the information where you will how you can choose the method. So interpretation. Here is the comparison assumption. Okay, and hypothesis assumptions. Okay, here you can see this is the one-way ANOVA formula. You can see here sum of the square we are given. This is the entire formula. Okay, then we have the, and from this formula what you observe, only x bar we have single mean. Okay, and here ANOVA table one way. Here we have the 2 groups. Okay, between 2 group we have, when we have the groups, in that case we will apply ANOVA one way. Okay, so between the 2 group we have a sum of the square SSB, and this is the entire formula. You can see here mean square MSB is equal to SSB upon K minus 1, and this is the F will be equal to F test is also there. Okay, so F test is also enrolled in the ANOVA table. Okay, so here you can see within the group error for the treatment for the error, this is the total. Okay, and these are some of the squares. Here we will use SSW. Okay, the value which we will calculate here, SSW, and n minus k. Here we have k minus 1. Okay, what are k? K is the number of the groups. How many groups are there? And what is n? See, this is the n. N is the total number of the observations. And x bar is group mean of all observations. Okay, and x bar I, this is the mean of group I. Okay, so we have the grouped information in the 3, 4, 5 from the entire population. Suppose that we have from the population we have 4 group or 5 group, and we want to compare them. Okay, so we can have I will vary from I equal to 1, 2, 3, 4. Okay, in this way. So if we have xi1, it means first group mean. If here x2 bar, it means mean of second group, and so on. Okay, and here are the null hypotheses for all groups. Okay, here and all these we will assume here equal. Hypothesis for all group mean are equal. Okay, mu1, mu2, mu3, and so on. And alternative, at least one group mean is different. Okay, so in the H0 we will assume all the means are equal, but in case of alternative hypothesis we will assume that at least one mean is different. Okay, so here independence, normality. What is the meaning of independence? Observation are the independent between 2 group. Okay, when 2 groups are independent. Normality, when the data in each group are approximately normally distributed. Okay, if you will compare first group, data is normally distributed, in the second group, in the third group. Okay, so all are approximately normally distributed. And third, we have the homogeneity of variance. The population variance are equal across the groups. In the all groups, we have equal variance. Okay, no outliers, and you are now familiar about what is the meaning of outliers. Okay, so this you can calculate with the help of box plot. Okay, that's why the previous study will help you for the better understanding about all these concepts. Okay, so how you can interpret all the conditions are described here. Okay, and you the manual formulas are given. You can apply all this. Okay, but this will be helpful when we will choose the real formula, real problem. Okay, so here this party which you can see reject S0. See the graphical part. This is the F distribution right skewed. Okay, so in the right skewed you can see this blue part. F value are always positive, so all the values which will be computed here are positive. And for the large value F, the stronger have the evidence against F0. Okay, so this part will be rejected as much you have the large value. But here also when you will apply for the real problem, actually the thing is all these information, the examples which you are observing here are valuable only if you are doing manually. But when you will apply for the real data set, okay, all these things are different. Okay, so we are not going to pass any examination. We want to understand how we can apply for the real data set, from where you can find some findings and you will be able to interpret. Okay, so the conditions which I show you at this page, in this case we have we are using F static. Okay, we are using here F static. This is the formula, and this is the decision rule. If F is greater than FCRIT, okay. But if you will compare with the help of p value, so this is somewhat critical, but p value help you reject or not. Okay, so p value is there. So when you will apply this test, p value for all type of the test which are exist in statistics for hypothesis testing. So along with the Python, when you will apply in the Python or any programming, p value will be there. Okay, which will make it easy to interpret. So the these values also you can interpret, but to take the decision without value of p, we are not able. Okay, so there are different conditions for all type of the test which you can go through entire sheets which I have created here. We required to spend some time on it to understand these concepts. Not remembering, you are not required to remember the formulas. You are required to understand the conditions and at what condition which test we can apply and what is the hypothesis test. So hypothesis, along with the hypothesis test, we have to apply test. Okay, in the hypothesis we will consider only the assumptions, okay, S0 and H1, but decision will be on the basis of only p value. Keep in mind. Chi-square we discuss. Yeah, we have discussed. So I have t-test, chi-square, ANOVA, and along with the, okay. So first you must cover all these concepts about these tests, okay. And along with what I will do, I will share the test using the ANOVA test, chi-square, with Python. Okay, here I think I have created. I have to check here. I create, but here I have the Spearman. Okay, t-test is there. Okay, I think in different folder they are exist. So all type of the tests which are essential, I will share with you. Okay, so some of them we have cover only one test. Okay, so in the coming session by tomorrow, so we will use all the tests which are applicable for data set. Okay, all the tests are not essential, but mostly which are useful, just like ANOVA test, the example we are required to discuss. Okay, and t-test we have discussed, and one more test, chi-square. Okay, so these tests also we will try to cover in the coming session by tomorrow. So dear participant, this is all about the today's session, and today I very speedily present the content. Sorry for that, because the content was large today. Okay, so during this time of spam, I am not able to present all the content. So partially the remaining content we will present it in the coming session by tomorrow. Okay, because all type of the tests are very essential, so you are required to spend some more time on all these tests, so that in the coming session, if you have any doubt related to any concept, please feel free to ask the questions. Okay, so right now I have to over the session because the next session is going to start now. I have very less time. Sorry, today we will not discuss any question. If you have, we can do tomorrow. Okay, so dear Faiz, you can conclude the session, and all the content which we have, I am going to share in the WhatsApp group. Okay, so at least which we have covered, you also do some practice on it.
As we conclude today's session, I would like to extend my sincere gratitude to Dr. Meher Chand for today's insightful lecture on correlation and hypothesis training. Today's session enhanced our understanding of how statistical techniques can be used to uncover meaningful relationships within data and validate analytical findings. By exploring correlation analysis and hypothesis testing, we learned how to measure associations between variables and determine whether observed results are statistically significant. These concepts are fundamental to data-driven decision-making and form an essential part of modern data science, machine learning, and research. I encourage everyone to revisit today's concepts, practice applying these techniques to real-world datasets, and continue strengthening your statistical foundation. A clear understanding of correlation and hypothesis training testing will greatly improve your ability to analyze data and build reliable predictive models. I would also like to thank all participants for your active participation, thoughtful questions, and continued enthusiasm throughout today's session. Your dedication and eagerness to learn continue to make this training program both engaging and enriching. Thank you all for joining us today. Have a wonderful night, and we look forward to seeing you in the next session.
Thanks, dear participant. All the content which we cover here, you can find in the WhatsApp group. So sorry for the today questions we are not able to discuss right now. If you have question in the coming session by tomorrow, we can discuss and you can put your queries. Okay. Thank you and good night.